Hello students, welcome to my class. Today I am going to reduce the differential equations of simple harmonic motion for electrical harmonic oscillators. Okay, and this is a very important topic for the engineering physics second unit, that is harmonic oscillations. Okay, and we take first year R18 syllabus for JNTUH Telangana state by Anand sir. So today we are going to see the differential equations of simple harmonic motion SHM for electrical harmonic oscillators. Okay, so this topic already you have learnt in intermediate second year in alternating current. Okay, so let us consider a capacitor and inductors. Okay, so with the help of the plug key, both are connected in series. Okay, so a plug key is opened in the beginning. So let us consider in inductor L and capacitor C, and key are connected in series. Okay, so what happens when key is closed? Then current flows. Before that, let us consider key is opened. This key is opened. When key is opened, what happens? Okay, and when key is open, the charges stored in a capacitor. Okay, and a capacitor is a device which stores the electrostatic charges in it, is known as the capacitor. Okay, before the key is opened, charges stores in a capacitor. Close చేసినాం అనుకోండి ఏమొస్తుంది? Close చేస్తే, and whatever the charges are stored in a capacitor, that charges started flowing in a circuit. Okay, కాబట్టి let us consider in an ideal condition the resistance R is negligible in the given circuit. Okay, so when switch is open, the capacitor is charged to a voltage VC. ఓకే, అప్పుడు ఏమవుతుంది? ఇక్కడ చూడండి జాగ్రత్తగా. ఓపెన్ చేసినాం అనుకో, ఈ కెపాసిటర్లో మనకు వోల్టేజ్ అనేది స్టోర్ అవుతుంది. స్టోర్ అయినప్పుడు అకార్డింగ్ టు కెపాసిటెన్స్ ఫార్ములా C is equals to Q by V in the సిన్స్లో చూడండి. The capacitance, the formula for the capacitance or the definition of the capacitance nothing but Q by V. C is equals to Q by V. Flow of charges per unit voltage. Okay, as the charges are stored in a capacitor, okay, its voltage will be increases. Okay, voltage will be decreases. Voltage will be by lowering its position. Okay, so the capacitance formula is nothing but it stores the charges per lowering its potential. పొటెన్షియల్ లోవర్ చేసుకుంటూ ఛార్జెస్ని ఇంక్రీజ్ చేసుకుంటుంది. అది మనకు కెపాసిటర్లో చూస్తాం. C is equals to Q by V. దెన్ Q is equals to VC into C అని రాసుకోవచ్చు కదా. Yes, from this C is equals to Q by V, we can write Q is equals to VC into C, then VC is equals to Q by C. Let us consider equation 1. And this is the charge on a capacitor is given by. This is the charge on a capacitor. So let us consider equation 1. When switch is closed, what happens? When switch is closed, the charges started flowing in a circuit, and that charges also passes through a inductor. Okay, inductor నుంచి కూడా కరెంట్ అనేది చార్జెస్ అనేది పాస్ అయిపోతుంది. As charges are passing through a inductor, a potential difference develops across the inductors. Clear? So from that we can write the current I is equals to dq by dt. Okay, so let us consider equation 2. Okay, and this current produces a voltage across the inductor. ఈ కరెంట్ మనకి ఏం చేస్తుంది? whatever the current which is passing through a inductor, okay, that current produces a voltage across the inductor. So that VL nothing but voltage across inductor, and this is equals to EMF. వోల్టేజ్ అన్నా ఈఎంఎఫ్ అన్నా సేమే కదా. సో కాబట్టి ద పొటెన్షియల్ డిఫరెన్స్ ఆర్ వోల్టేజ్ ఆర్ ఈఎంఎఫ్ ఈజ్ ఈక్వల్స్ టు L into di by dt. this will get from the self inductance. Okay, self inductance nunchi manaki idu vastadi, self inductance nunchi. Okay, what is the self inductance? So that is the self inductance. So L is equals to E by di by dt. దాన్ని మనం ఇక్కడ ఏం రాసుకుంటున్నాం, E is equals to L into di by dt అంట, di by dt. ఓకే, సో కాబట్టి మనం సో ద EMF of the inductor which is equals to voltage across the inductor అని చెప్పొచ్చు. సో ఈక్వేషన్ 3 అనుకోండి దాన్ని. ఓకే, నౌ so there is a voltage is there and there is a voltage across capacitor and voltage across inductors. So and this circuit is looks to be a closed loop. When key is closed, it's to be it is looking to be a closed loop, so that we can apply Kirchhoff's second law or Loops law or voltage law in the closed loop. ఈ సర్క్యూట్లో మనం అప్లై చేయొచ్చు కదా. సో వాట్ ఈస్ ద Kirchhoff's second law here? The Kirchhoff's second law always talks about the voltage across closed loop. Okay, sum of the voltage across closed loop is equals to 0. That is the sum of voltage around the or across the closed loop equal to 0 or closed circuit equal to 0. That is VC plus VL is equals to 0. VC plus VL is equals to 0. ఇక్కడ చూడండి, సో VC అంటే Q by C and VL nothing but this is L into di by dt. So Q by C plus L into di by dt. Okay, this is equal to 0. అక్కడ మిస్ అయింది చూడండి, ఈక్వల్ టు 0. ఓకే, సో నెక్స్ట్ వన్ వీ కెన్ రైట్, సో Q by C plus L into di by dt. I అంటే ఏంటిది, కరెంట్, దట్ ఈస్ ఈక్వల్ dq by dt. సో ఇక్కడ రాసేసినాం చూడండి, I ప్లస్లో dq by dt అని రాసేసిన ఈక్వల్ టు 0. So Q by C plus L into d by dt of dq by dt ante d square q by dt square equal to 0. Okay, and when I bring this Q by C outside, okay, when I bring this Q by C is okay right side, that is minus Q by C వస్తుంది. Okay, and L ని ఇటు సైడ్ తీసుకొచ్చినాం అనుకోండి, ఈ L ను when is L is bringing this side, we can get this minus Q by LC వస్తుంది, Q by LC వస్తుంది. And this is d square q by dt square is equal to minus q into 1 by LC అని రాయొచ్చు కదా, 1 by LC అని రాయొచ్చు. సో కాబట్టి this 1 by LC we can write which is equals to this omega is equals to under root 1 by LC. So this is angular frequency. Okay, so in LCR circuit there is a angular frequency. So this will get from the capacitive reactance and inductive reactance. When capacitive reactance or inductive reactance are okay, if you see this, okay, I will use a brush so that you can understand. So if you see this capacitive inductance and capacitive reactance, so Xc nothing but capacitive inductance, that is omega C, okay, and XL nothing but 1 by omega L, that is inductive reactance. Okay, and when both are equal, then resonance will be formed in a LCR circuit. Okay, then omega square we can write here, omega square is equal to 1 by LC. Clear? So here we need to have the 1 by LC. Instead of 1 by LC we can write omega square. Clear? I hope you understand. Yes. Okay, so here we can get this. Yes, 1 by LC nothing but omega square. So this is d square q by dt square plus when this term is bringing left side, we can get plus omega square into q equal to 0, and this equation is known as the differential equations of simple harmonic motion of electrical harmonic oscillator, So this is the topic of today's, that is differential equations of simple harmonic motion for electrical harmonic oscillators. So thank you for watching this video. Please do subscribe my channel. Do subscribe Okay, follow all the education bulletins and also BTech classes and intermediate classes. Thank you so much.